On our next page, now we have some mixed practice. We're going to go through each of these cases on the front side of this page and determine which method to use, and maybe I'll complete a couple of these examples. Taking a look at exercise 1, I have a side, an angle, and a side. Do I use law of sines or do I use the law of cosines? Well, let's take a look. Do I have any angle across from a side? I do not. I would use the law of cosines. Now, which variation of that formula would I use? I have one angle, angle A. I would use the law of cosines, so let me write cosines here. And I would set this up by doing like a squared equals b squared plus c squared minus 2bc cosine of angle A. That's what I would use to set this up. Then I might want to switch it to law of sines later. I do have to worry about ambiguous cases sometimes, but let's just keep moving on. Let's try to figure out what our next one would be. I have two angles and a side. Do I have the angle across from my side length? Well, yes and no. It's not labeled for us, but really, if you're given two angles, then you really could find out the third one. So this one I would use the law of sines, because technically we could figure out what that angle is across from the side length. So I'd use the law of sines. What would I use it to find? To find angle A. So I'd set up sine of A divided by 9 equals, and then whichever I wanted to do next, like sine of 101 degrees divided by little b. And I would set this up after I found the angle A using your triangle sum theorem, and then we'd keep going. Let's take a look at questions 3 and 4. Let's see, I have a side but not an angle across from it, another side but not an angle across from it. I have an angle but no side across from it. This one is another law of cosines. We would use the law of cosines and first find side C. You would do c squared equals a squared plus b squared minus 2ab cosine angle C. So we would use the 95-degree angle and plug it in here. We'd plug in the values of side A, which is 22 and 20, and we'd plug them in everywhere, square root both sides, solve for C, and then figure out where we move on from there. How about this next one? Number 4, I have 3 side lengths. I have an angle across from a side. Which method would I use for this one? Well, technically I could use both. I could do side, 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 and then find one of these angles, or I could just use the law of sines. So this would be either one. It's an interesting one. They gave us more information than they had to. How about 5 and 6, where I don't see any pictures? So in question 5, if I were to draw this out, I can it might help me visually to see what it is, but I notice that this side is across from this angle. So this one I would use the law of sines, and I would find angle C first. So I do like sine 70 degrees divided by 25 equals the sine of angle C divided by the side length C, which is 26. I would set that up. Last one, B, A, B. Okay, I have a side across from an angle. That measured angle means that I am going to use the law of sines. So we'll do sine of 73 degrees divided by 5, which is equal to the sine of sine of angle A divided by 7. So here's the thing. Now I'm worried because I don't have pictures, and usually what helps me to determine if it's ambiguous case is seeing these. So I'll draw a quick sketch, label as best as I can A, B, and C. So A is 70 degrees, 25. Angle C, we don't know. 26. Look what it is. Small side, long side, angle. This would be the ambiguous case. So we have to be careful about question number 5. Draw like another triangle like A, B, and C. I'll just switch it up a little bit just for some variation. So angle B is about 73 degrees. Side length B is 5. A is side length 7. Small side, long side, angle. It goes this way. This goes counterclockwise. This is another ambiguous case. So it might be worth completing maybe either of these two exercises. So let's take a look. Let's see what happens when we do question number 5. Alright, so we're going to get that calculator out and let's see what happens. Alright, these are the two numbers. I'm going to multiply and divide, then take an inverse. Let's clear that calculator. Here goes. What's 26 times the sine of 70 degrees? Then I'm going to divide it by 25. And I'm going to take the sine inverse. So this tells me the measure of angle C is 77.763 degrees. Okay. If I do this, let's find its complement. Sorry, let's find its supplement. Why did I say complement? That was weird. 102 degrees. Okay, so this would be the supplement. Is it possible for me to like swing this length inside here and make a second triangle? Let's find out. If I did that, the supplement would be 102 degrees, and 70 plus 102 is less than 180. Yes, this would have two separate answers. So we're going to say C1 and C2. C2 is 102.237 degrees, the supplement of this. Alright, since I have this value in my calculator right now, what I think to do next is, why don't I find the measure of angle B? Let's add 70, and then let's subtract this answer from 180 degrees. That gives me the measure of angle B. That small letter B, that small angle, is 7.763 approximately degrees. So that would influence the second value for the side length of B using that angle, 7.763 divided by little b. I'm going to set this up, the first and the last added, so we're going to set 25 times this, divided by that. So let's do 25 times the sine of, let's use this full answer. Then I'm going to divide it by the sine of 70 degrees. And that gives me the value for the side length of B, of the second side length of B, which is weird because it's the one I found first. So really, that is the first one by default. All right, let's go back. Let's use this value. Now I want to get it back. Let's see if I can go all the way up. And I use the answer, so I would do this. So what did I do to do this? To find C, I did this times this, and I divided by that. Then I'm going to use the sine inverse. So second sine inverse of second my answer. Okay, there's that first angle. So now what? If that were the angle, what was the original B then? If I add 77 and 70, and I subtract that from 180, I get the original B value is 32.237. And now what would happen is when I set this up using the original angle for B, 32.237, that's going to influence the first side length of side B. So that would be this length right here. Okay, here goes. So I'm going to do this times this divided by that. So 25 sine second answer divided by the sine of 70. That gives me a length of 14.191 units. Okay, so we did have an ambiguous case on this page, just so you know. That happened because if I had small side, long side, and angle, this side length of 25 could pivot in this way and give us a much smaller possible second triangle. That was kind of neat, and I guess this really reviews how to set things up. Sometimes you have information where you want to use the law of cosines. Sometimes you have information where you want to use the law of sines. Just be careful if you're using your law of sines. There may be potential for there to be more than one possible answer, and that's your ambiguous case when you have a small side, a long side, and an angle. We're going to stop here and wrap this up. Here we go.